Hey, hi everyone. A very good evening. A warm welcome from Edureka. This is 𝐂𝐵𝐻𝐿, your trainer today. So, what we're going to learn today? We are going to learn text mining and sentiment analysis in Python using NLTK. So, let's try and understand what is text mining, what is sentiment analysis, what is NLTK, how it is used, and how it is helpful. All right. So, without further ado, let's get started. So what will be the agenda for today? We have four agendas, like what is NLP, right? We are going to understand what is NLP. Then we'll see what is NLTK. Then we'll see to naive-Bayes algorithm, very famous classifier algorithm in machine learning. So we'll touch upon that as well. And then we'll understand what is sentiment analysis. All right. So let's get started. So this is a very famous certification course of Python offered by Edureka, and I'll just show you a couple of glimpses. So we have a lot of modules here. I am also a trainer in this particular course. I know this is really good and industry aligned, right? So a lot of milestones are there. We'll see what is introduction to Python. We'll see sequences and file operation, how we do it in Python, right? And then a lot of hands-on. Can you see even after like every module, right, we are going to have some hands-on, right? Can you just see working with the files, right, handling exceptions, then hands-on, then introduction to NumPy, very famous library in Python, very famous, right? Then can you just see we'll jump into pandas, very important library when you talk about data analysis and data science, machine learning, right? So everything uses pandas. All right, then every module has got associated with the hands-on training. Then we'll cover up the matplotlib, which is famous visualization library. So can you just see we'll come with the GUI programming. A lot of things are there, right? And after that, you will become a Python expert, right? So I can say that because I know about this course and I know the importance. Okay, so this is nothing but the self-paced courses. Let's come to the agenda of today, that is NLP. We have to understand what is NLP and then we'll see how we are going to benefit out of it, right? So NLP is nothing but natural language processing, right? So what do we do with the NLP, right? Whenever in real time, if you supply any kind of voice command or any kind of textual information, on websites, so they basically analyze your information. So the information that you are trying to transmit is in your language, that is natural language. So in NLP, we try to develop such an applications which can recognize the natural language, which can understand what is the meaning of those information, right, and try to make some decisions out of it, right? So that is nothing but NLP. Let me just talk about a very simple example. Let's say if you are on some e-commerce website like Amazon or Flipkart, you are purchasing something and you are trying to give some feedback about that product on those portals. All right, so basically you are feeding the information that you want to express, right? But that is going to be in your language, right? So machine is going to understand what you are trying to say, whether it is positive, negative, or neutral. So with the help of those information that you are supplying, they are trying to understand what are the views of the customers, right, about their products, right? And they make changes according to that. They might be offering some discounts on that and a lot of things. They might decide some sales strategies, marketing strategies according to that. Let me just give you one more example, right? You might have seen Apple Siri, Google Alexa, right? I mean, we have to give some voice commands to those bots, right? So basically, they are responding to our voice commands. So how they are understanding what we are trying to say. So if I call it, hey Alexa, what is the time right now? So this is in natural language that we are transmitting, right? So how the machine is going to understand that what I want or what anyone else want? Are you getting this? So this is nothing but NLP. We try to study the natural language using the applications and we try to act on that, right? So this is NLP pipeline, right? It's not very, I mean, very straight away thing. The data has to go through a lot of stages, right, to come with the final product or final decision, right? So you can just see this is the NLP pipeline in which you can just see when your information, which is in the form of text, or we can say that it's a textual information, right, that you are passing through different stages. Like first stage is sentence segmentation, so in which we try to segregate your entire information into sentences. That is called a sentence tokenization, right? And the next step is tokenization, basically. So tokenization is nothing but segregating your words. We'll touch upon these things, don't worry. So you can just see we have POS tagging, right? And then we lematize the word, we remove the stop words, then we parse the final thing after stopping the words. Okay, then we create some noun phrases, and we identify the information behind the scene. Okay, that is nothing but the process text. So this is your pipeline in NLP. The data has to pass through all these things to be ready to be understood, all right, by your system. Are you getting this? So this is nothing but NLP pipeline. Don't worry, I'll show you how it works. Okay, so here a very important part in this NLP pipeline is nothing but data cleaning. Why I need to clean the data? Is data is dirty? Yes, it is dirty. Why it is dirty? Let me just tell you. The information, textual information that we are getting from different sources, it might be web portals, might be, voice commands, might be any other form of information that we are collecting, are not ready to be used in the NLP algorithms as it is, because there are a lot of inconsistencies in data, right? The data might be null for some time, right? Data might be containing some irrelevant words, right? A lot of things are there inside that data, right? The data has to be clean before actual use, right? So we have to perform a lot of cleaning tasks, like we have to perform tokenization, we have to remove some stop words. I'll talk about this stop word, right? What is the stop word and why we need to remove it. Then we'll talk about stemming and lemmatization. These are nothing but the converting the words, because since it's a textual data, right? So we need to convert those words into its base form, so that I'm going to tell you how we do it using NLTK, and that is the place where the NLTK come into the picture. All right, so now we'll see what is that. Let me just talk about some of the very common terminologies that we use in NLP, right? That is nothing but vectorization. When I talk about vectorization, so vectorization is nothing but process of converting words into numbers. Because at the end of the day, we are trying to make use of those data into machine learning algorithm. And if I talk about machine learning algorithms, we have mathematics behind it, right? We have statistical inferences. We have a lot of things which are related to mathematics. All right. Then probability is also a concept which is there inside the naive-Bayes algorithm, which we are going to touch upon. So here, what do you mean by vectorization? Vectorization means we can't deal with the strings all the time. Okay, we can't perform any numerical operations on the textual information. So what we do is we try to convert the textual information into numbers, right? So that the numbers can be used now to be calculated something. We can just pass that data into the machine learning algorithm so that it can process it and find out something for us. So that is nothing but, so you can just see this in example, right? We have a text, right? Can you just see the cat set on the mat? So basically we tokenize these. So we have just divided whole textual information into parts, especially in the words. And then can you just see this is vectorization token, right? So that is how we convert the data. So there are a lot of methods we can do that, right? So it is like little deeper concept, but I hope you got the broad idea about the vectorization, right? I'll show you that. Then when we have cleaned the data, we have transformed it into numbers, then it is time to perform the classification. It is one of the very important process in machine learning, or you can just say it's a type of problem that we have in machine learning. So basically classifier means we have to segregate the input data into different classes. Like for an example, we receive a lot of emails in our inboxes, right? So some of them are good enough, right? Some of them are like really useful, but some of them might be spam, or some of them might not be useful to you. So it's a very simple example. Then there's a classifier in between. So I mean, the classifier is mathematically nothing but the algorithm which reads the data and try to take some decisions. So classifier chooses the information, or right now in this particular example, the emails, and segregate the emails into the inbox and the spam folders. Are you getting this? So basically, the data is given as an input. The classifier, the responsibility of classifier is to classify them, categorize them into different classes based on the content, based on the given criteria, right? That's what we are trying to do using a classifier. Here also, if I talk about the sentiment analysis, so let's say if we are studying the tweets, right, about some company, so they might be negative, they might be positive, they might be neutral as well sometimes, right? So these are nothing but the sentiments that we are looking for. And at the end, sentiments are nothing but the classes, right? Are you getting this? So basically, when you supply any tweet to the classifier algorithm, it will classify the tweet it will classify the tweet as positive comment or negative comment or maybe neutral comment, like that. Or if you want to segregate it, then we can also go for like very bad, bad, neutral, good, very good. Are you getting this? So these are nothing but the 5 classes that we can classify. Okay. So at the end of the day, sentiment analysis is nothing but the classification that we try to perform, right? You can also think about a product, right? If any product is being purchased by the customer, and the customers are likely to give some feedback, okay? And the feedback is negative, positive, what people are thinking about the product, right? So that is nothing but good or bad, or maybe neutral sometimes, right? So that is nothing but again classification. Try and remember that thing. The input that you are trying to give is nothing but textual information, right? You are doing it in your natural language, might be English anytime, right? So you are supplying your information in the form of English. There is an LP, right? And the machine is trying to recognize it. Okay, so I'll show you how we do it. Now let's talk about the NLT. It's very, very interesting. So what is this NLTK, right? Let me just tell you, NLTK is a very popular library in Python to deal with the NLP task, right? So whenever we want to do some natural language processing, then NLT is the first library that come into your mind. It's very popular. And NLTK is nothing but the natural language toolkit. So it's a toolkit. Basically, it's a tool, right? It's an open source tool which can be used, to perform some processing on textual information. So it has got everything that is required. Okay. So I'll show you NLTK in action. Don't worry, in a couple of minutes only. All right. Then we'll cover up the naive-Bayes algorithm. The naive-Bayes algorithm is a very famous algorithm to do classification. Remember that I discussed about the classification. So there are a lot of algorithms which can perform classification for you, but specifically for textual type of data, textual information, naive-Bayes algorithm is the best choice. That's why we have chosen naive-Bayes for this demonstration of NLTK. A lot of common terms which we have to cover here. This naive-Bayes I'll discuss. So before jumping into naive-Bayes algorithm, let's try and understand NLTK and how it is helping us to perform natural language processing. All right. So let's try and understand that. For that purpose, I'm going to use the Jupyter notebook, and I'll show you some code just to save some time. I have already prepared some examples for you. All right, because I have to cover a lot of things. So I thought just not to waste our time in typing, just prepare something and just show you. All right, so let's try it, and let's do what we can do using the NLTK. All right, I hope it is visible. Let me just zoom it a little bit more. Right. So can you just see, I'm just trying to give you the introduction to NLP using Python. And when I talk about NLP using Python, NLTK is the best choice, right? So if you remember NLTK, right? NLTK was nothing but natural language toolkit. Okay. So in Python, before using any of the library like NLTK, like pandas, NumPy, we have to get it installed, right? Then I have already installed it. And then the next step is import NLTK in your code. So if you can see the code here, right, I'm importing NLTK, that is importing natural language toolkit, because I want to use the functions and other things which is available in NLTK. Okay, let's try and understand NLTK, and then I'll show you a couple of things. Okay, there are few steps that you have already seen on the PPT, right? That we need to understand, and then I'll show you, their meaning and with an example. Okay, here, there are a lot of things that you need to understand. Let's try and start with the first thing, that is tokenizing. Let me just talk about the tokenizing, right? Tokenizing is nothing but a process of splitting the textual information into sentences first, and then it can be further divided into words. Okay, so there are two type of tokenization. That is nothing but sentence tokenization and word tokenization. So let's try and understand with an example, and then you will see it in action. Okay, so can you just see that here I have imported the NLTK, and I have also imported the sentence tokenize and word tokenize. So we have built-in functions inside it, okay, that can basically do this task for you. All right. If you can just see, I am having an example. Can you just see? This is basically paragraph, right? Which is telling something. Okay. So basically, if you can just see this paragraph, right? We'll see, and we can divide the whole paragraph into sentences first, and then we'll do the word tokenization. Let's do it. Then only you will understand. Before going ahead, let me just explain you what is this NLTK.download and Punkit. So basically, let me just talk about it. It is nothing but a repository kind of thing where all the punctuations related to the English grammar is already being stored. So NLTK is having a lot of bundles which is related to English language, which can help us to identify the punctuators and other stuff when we supply textual information to it, right? So what we can do is we can download it into our code and directly use it, right? We don't have to create our own grammar. It's already there. So can you just see punctuation kit? So I have already downloaded it, right? If I run it, can you just see? It's going to download the latest one. They keep on updating the library. Okay. You can just see it is running right now. You can just see that. It is downloading the package, and the package is already up to date. Can you just see that? Okay, so I have an example. I have an example string. Can you just see that? Right. And I'll perform the tokenization on that. Okay. So first of all, the paragraph is being converted into multiple sentences. Right. So let's try the sentence tokenization. Okay. What I can do is I can restart the kernel, right? So that you see this output after running. Okay. So let me just restart and clear all the outputs so that you can see everything fresh. Yes, now it is ready. So can you just see, let me run this again. Okay, so I got everything up to date. Now what I need to do is, can you just see what am I trying to do? I am using the sentence tokenize, which I have just imported from this NLTK, right? Can you just see sentence tokenize? And sentence tokenize, I have provided the example string which I have just defined here. Can you just see that? Now, after doing this sentence tokenization, just check out the output. Can you just see that? What is happening here? The whole paragraph is being divided into sentences. This is the very first step. Can you just see that? Right. This is the sentence one, and after that, comma separated sentence two. I mean, this is entirely based on the punctuations. Can you just see dot here? Right. So whenever the full stop is coming, then it is segregating it into a different sentence. So this is the very first step. Now what we have to do, we have to supply these strings or these sentences into word tokenization, and so that we can divide the whole sentence into words, right? That is the second step, and it is the part of tokenization only. So let's try it. Word tokenize, what I have imported here, if you remember in NLTK tokenize. Okay, so can you just see when I run this? So I got everything segregated. Can you just see that? And right now it is on the basis of white spaces that we have. Okay. So basically it's a word tokenizer, right? So every word is being segregated. Can you just see? Learned rapidly because his first training was. Can you just see that? Right. So everything is segregated, even though we collected a dot as well. Right. So that is also a process of word tokenization that we have to perform, and that will segregate the entire sentence into words. See, every word in the English sentences is having different meaning. All right. So we have to understand each and every word to understand the overall meaning of the sentence. Is that correct? That we perform, right? The same way we have to perform in NLP. So this was the step of tokenization, right? Now, as a next step, we have to filter the stop words, right? So what is the stop words and why we need to remove them? Why we need to filter out them? Right. So, what are those stop words? So, stop words are nothing but the words which are first of all frequently used in the sentences, English sentences, and they don't have any direct impact on the sentiment analysis or any other thing. Are you getting this? So, basically the stop words, the words that you want to ignore. Okay, like in, is, and these words are oftenly used in your English sentences, right? That can be stopped. So what we have to do is we need to remove these words because there will be repetitive words inside that, right? And that will be disturbing. Okay, so you can just say stop words are the words that you want to ignore. And so what do? You filter out them from your text, and you can do this stop words processing by the stop words repository. So again, NLTK is helping you. No, so NLTK has got a bundle of stop words. It has got stop words, and what we need to do is we just need to compare our data with the information of stop words which is already available in NLTK. And then when we compare it, all these stop words which are commonly there in the English language will be removed. Okay. Now, let's see that. One of the important term that you will come across here in this NLT is nothing but the corpus. Right. So corpus is nothing but the information, the entire information. So if you remember, so we had this particular paragraph. So this is called corpus. So entire information is called as corpus. Okay. Then we tokenize it to further segment it, right? That is nothing but corpus. Okay. So that's the important word. Then you need to understand. Okay. So to compare that stop word, we need to install, or we need to download the stop words that are already there in NLTK. Okay. So let's install them. Let's download them, right? Let's update it. And then what we are going to do is we are going to do the stop word removal. Okay. So let's run this particular part. And you see it is already up to date. So no changes. All right. But this is a good practice. You always keep on updating because there might be some updates on that. Okay. Here I'm giving you a very simple example, right? Just to understand the stop word removal. So you can just see I have a code, I have a code that is WAF code. Can you see, sir, I protest, I am not a married man. So this is a sentence which first we are going to tokenize. So we'll segregate them into words and then we'll remove the stop words, right? So let's run it. So can you just see I have tokenized this particular sentence into words. So can you just see, sir, comma, I protest dot I. You can just see that. Now what I'm going to do is I'm going to compare this tokenized information with the stop words, right? So what I'm going to do is I'm going to store the stop words coming from the English part of the stop words, which is coming from the NLTK. Remember that I have downloaded it, so I can use it. No, so I have converted into set so that it can be unique, right? And then can you just see I have created a filtered list, and with the help of a for loop, right, I have compared my words with the stop words. And after comparison, the words which are not there in the stop words will be filtered out. And you can also check out this case fold function. This case fold function is a very simple function which ignores the cases, right? We'll ignore the cases here. So can you just see sir? So S is capital here, right? So we'll ignore these cases, all right? And we'll remove it. So after doing that, let me just show you the outcome. Okay. So here, can you just see after doing that? So the code executed successfully. Let's check out what are the filtered result words that we have. Okay. So let's run it again. So can you just see after doing this filtering, right? We got sir, protest, merry, man, and some punctuations are also there. So you can just compare it. I have passed this information and there are a lot of stop words which are removed. Can you just see M, A, right? I, they all are removed. Can you just see that? This is very important process, so that we can have relevant information only. We will not be having some repetitive information. I mean, processing the repetitive information doesn't make any sense. Okay. So here is a very simple example. That is this. Okay. Now, coming to the next part, that is called as stemming. Right. So there are two things that we do in NLP. That is stemming and lemmatization. Okay. So when I talk about stemming, it is nothing but the process of converting your word into its native form or maybe a root form, right? Because you might be having some words which is like added with the ing form, or it is some form of verb, right? Might be anything. So the process of stemming is nothing but converting your word into its root form, right? To understand its core meaning. That is the whole idea behind the stemming. So you can just check out the stemming is a text processing task, right? In which you reduce the words to their root, right? We try to reduce it to the root, which is the core part of the word. Okay. So here we are trying to do some stemming, right? So let's try and understand with an example so that so this is an example. It's a very good example, by the way. So let's say if we have word like helping, maybe helper, right? Now, the words like helping and helper can be converted into its root form, that is help. Look into that, right? So we have help as a root form of the words like help, helping, helper, right? Like that. So that is the process. So help is a root form. So we this is nothing but the stem form, right? We have stem in cells, right? That is nothing but the there is nothing but the root. Okay. Okay. So let's try and understand how we perform the stemming. Let me just tell you, we have a lot of stemmers, in NLTK, but the most popular stemmer in NLTK is Porter stemmer, right? There are a lot of methods we can perform this stemming task, but when we talk about NLTK, I think Porter stemmer is the best choice. All right. So can you just see, I am importing Porter stemmer. Look into this, right? Let me just zoom it a little bit more so that you can see that. Can you just see from NLTK stem? This is root library, NLTK and submodule stem, and I am importing Porter stemmer. And we have to every time do this work tokenization because I'm having different different sentences every day, right? So we have to perform the stemming. Okay. Look into this, right? What I'm going to do is I'm going to create an object of this Porter stemmer, and this object is going to work for me and do the stemming. Okay. Now, can you just see, I am creating the Porter stemmer's object here, right? And I have string for stemming. So look into the example. The crew of the USS Discovery discovered many discoveries, right? Discovering is what explorers do. So can you just see a lot of similar words, right? Here, every word will have same meaning. Getting it? So what we need to do is we need to convert these words into its base form. And that is what is nothing but the stemming does. Okay, let me perform the stemming and then I'll talk about the lemmatization. Okay, lemmatization is again the same process, but it is a little sophisticated. So when we talk about the speech recognition kind of application, then we perform lemmatization. Okay. The base form is called as lemma. All right, let's perform lemmatization and let's see what we can do. So for that, first of all, I am converting your entire input sentence into words. Okay, let's run it again. You can just see I have converted it, and let's try and let's pass these words. This is already tokenized word. Let's pass it into stemmer, to get the uh, stemmed words. So can you just see that after doing this word tokenization, right? We are performing the stemming, right? You can just see I am performing it using the list comprehension. Here it is called as list comprehension, which I am trying to do it using using this function, that is stem. Okay, this is a stem function in which I am providing this word, right? In which is available in words. Can you just see words is nothing but the group of tokenized sentences. I hope you're getting this. Okay, let's try and understand what is going on, and let's try run it now. Can you just see that every word which was there, like discovery, discover, discoveries, is being converted into its base form? Can you just see it is discovery, discove, right? Discovery, again discove, then explorer. If you can just see explorer, right? That we have explorers is becoming explore. So that is nothing but converting your words into its base form, right? That's what we do here in the stemming. Okay, I hope you're getting that, right? So let's move ahead and let's try and understand the further part. Okay, so we have done the stemming. Now the next part is POS tagging. This is very interesting thing, that is POS tagging. So what we do using POS tagging is nothing but tagging some POS, that is part of speech tags, to the words that we have just tokenized, right? Just to understand the proper meaning of the word, right? So again, NLTK is going to help us, right? So you can just see it is grammatical terms which is going to be attached with the words, okay? Like the word is noun or pronoun, or it is a verb, or it is adjective, or any conjunction, disjunction. What is that, right? So everything is available in like NLTK. Now here, what we're going to do, again, lot of taggers are there. I mean, we try to tag the part of speech. A lot of taggers are available in NLTK, but the best is average perceptron tagger, this NLP based tagger, which is the best choice for the POS tagging. So can you just see POS tagging here? What am I trying to do? So I have 𝐶, right? And I have some words inside it. I will first tokenize it into the words, and then I'll try to tag POS tags, to these words. Okay. So let's try it and let's see what is going to be the results. Right. So if you see the word, the words are now at, the words are now attached with something. Can you just see if, right? So the code says if you wish to make an apple pie from scratch, right? So can you just see if you wish to make an apple pie? So everything is connected. Can you just see this is apple is a noun, right? NN means noun, right? Make is actually a verb, right? Can you just see maybe a perfect verb, like I mean it is hardcore English grammar, right? Can you just see that? So verb is there. You is nothing but the pronoun, right? So can you just see every word from the word tokenized data is attached with the POS tag, just to understand the proper meaning of the word, because sometimes in English a word can also be used as a verb and can also be used as a noun, right? So just to understand the proper meaning, the POS tagging is important, and this happens every time when you work with the work with the NLP. I've also told you about the lemmatization. Lemmatization is a similar process of stemming. It also converts the word into its base form, but it is more sophisticated. It takes care of the English grammar very much, right? So you can perform the same thing, right? I am not going deep inside it. Instead, let's come to the knife-based algorithm. We have seen a couple of things. There are a couple of more things like chunking, chinking, right? A lot of things are there, but I'm not going deeper inside it. because these are like little advanced level topics. We need some background before understanding it, right? So instead of that, let's understand the naive-Bayes algorithm, right, which is going to be very interesting. Okay. So to understand the naive-Bayes algorithm, let's try and understand what is this, right? With a PPT that I have, right? So I have already told you the naive-Bayes algorithm is nothing but a classifier algorithm, which is nothing but the algorithm based on the Bayes theorem, right? If you know about the Bayes theorem, then it might be very useful. Okay, so if I talk about naive-Bayes classifier, it is a supervised machine learning algorithm based on the Bayes theorem, sorry. And the Bayes theorem is nothing but a classifier which is based on probability, the concept of probability. So that's why it is called as probabilistic classifier, right? It will try to predict the things on the basis of the probability of the object. Are you getting this? A lot of use cases are there where the naive-Bayes algorithms are used. And you see spam filtering, sentiment analysis, the best use case. Because naive-Bayes algorithm is best choice among all the classifiers when our input data is textual. Okay, so here there is a naive-Bayes classifier, and this is the Bayes theorem, by the way. I'm not going deeper inside it. There are different probabilities which are associated with the Bayes theorem. That is P by A, that is nothing but the event, right? A and B are nothing but the event. Okay, so can you just see? I am trying to segregate, sorry, I am trying to predict, right, the posterior probability of A. What do you mean by posterior probability of A? A is to B. So what is the probability of A happening when B is happening? Are you getting? Like for an example, if I am buying bread from a supermart, right, grocery mart, then what is the probability that I will also buy butter? Are you getting this? This is the kind of thing that we are trying to predict. Okay. And B of A is nothing but the likelihood probability. What is the prior knowledge that we have? How many times people buy bread along with the butter? That is known as likelihood probability. Okay. And then P of A is nothing but the probability of event A, and then divided by probability of B. This is called as B. This is called as prior probability, P of A, and this P of B is called as marginal probability. Just to make it understand, I mean, in a simple words, right? I have given an example, and the example is pretty simple to understand, right? Here, um, I have a bunch of balls. Okay, I have a bunch of balls, and I have 20 red balls and 40 green balls. Okay, I have one more ball here, right? But I don't know what what class it will belong to. Will it be red or will it be a green, right? So I am trying to predict the probability of newly added ball, whether it belongs to the red group or green group. So I am here trying to predict that. Okay. So basically, can you just see the task is to identify the color of newly observed dot or ball. Yeah, right now it is dot, or you can consider it ball, no problem. Using the naive-Bayes algorithm, right? So it's very easy to understand, don't worry. So if I talk about the prior probabilities of green and red, it's going to be like 40 divided by 60. Why? Because the number of green balls available is already 40. That is prior probability, that I know it already, prior probability. That 40 is the green balls and 60 is total balls. Okay. And when I talk about red, it is 20 divided by 60. Getting it? So that is the prior probability that I already have. Now let's try and understand what is going to be the um, uh, the the possibility or likelihood probability of the newly observed ball, and I mean which it belongs to, right? So let's try and understand. So if you see the likelihood of this being red, so what is the likelihood that it is going to be a red ball, right? It's going to be red ball, and the formula says that number of red in vicinity. So if we take out some surrounding balls, right? Surrounding balls. So we'll check out how many balls are there which belongs to the red group and how many are there in the green group, right? Around the newly observed ball, right? So divided by total number of red and similarly green. So let's calculate it. So can you just see that? You can just see the posterior probability will be prior probability of green multiplied by likelihood probability of green, right? So likelihood probability of green is 1 divided by 40. Why? Because in the vicinity, in the surrounding of the newly observed ball, there is only one green ball, right? So basically, the ball is more close to the red group, right? That is what we are trying to do, right? So here, the prior probability is 40 divided by 60 that I already know, multiplied by 1 by 40. That is my likelihood probability. And similarly, the prior probability of red is 20 divided by 60, right? And the likelihood is 3 divided by 20. And it is clearly visible that the X, which is newly observed dot, belongs to the red ball, right? Why? Because it achieves the larger posterior probability. So the probability of that newly observed ball is higher than to the green. Even though, if you can just see the general scenario, there were more green balls than the red one, but still the new ball which we found belongs to the red one. Are you getting this? So this is nothing but the naive Bayes algorithm, right? Let me just show you an example, right? And then you will see this naive Bayes algorithm and sentiment analysis in action. I mean, how these are combined: NLP, sentiment analysis, and naive Bayes algorithm. Let's see it in a combined way. All right. So for that purpose, I have used an open data set that is Swiss about the Virgin America airline company. Let me just show you that data set. Okay. So the data set is here. Yes, Swiss. Why it is not opening? Yes, it is opening now. Yeah. So here, can you just see it's a huge data set, by the way, right? A lot of data. Can you see tweet ID here? Then um, airline sentiment. Can you just see this is the sentiment which people have tweeted about the Virgin America flights. So let's say I have used the Virgin America services, and what things I found. Right. So there are a lot of tweets and their sentiments like neutral, positive. Right. Can you see negative as well sometimes, right? So depending upon the segregation, there might be there. I can just see the tweets as well. I mean, the airline company is Virgin America, and there are tweets as well. Can you see tweets? So this is the textual information that we are interested in, right? Can you just see at Virgin America what different said, right? Can you just see a lot of tweets are there? Look into that, right? Can you just see that, right? Seriously, would pay $30 a flight, right? Can you just see a lot of tweets are there? Some of them are positive, some of them are negative. So can you just observe? My task is to find out, I mean, how many of them are positive and how many of them are negative. And in future, if I have some other tweet, then can I categorize it into the different sentiments like positive, negative, and neutral based on the previous learnings of the tweets? That's what we are trying to perform here. Okay, so we are trying to do this right using naive Bayes algorithm. So we'll classify this using naive Bayes. Can you just see that? What I am trying to do, I am using pandas, which is also very important library in and which is covered in our Python certification program. Right? It is, I mean, everything is covered in that program, especially pandas. Okay. Now, I've imported NLTK as I need that. Right. And I have also read the data from that CSV file that I have just shown. That is swiss.csv. Okay. And just to check out, I have just called this head function to check out the top 5 rows of that particular data frame, right? This is nothing but a data frame here I'm using, right? So let's run it. So let me just clear the output so that you can see everything new. So let's run it. So let me just zoom in. All right. So let's run it. So I have imported everything. I have read the data. Right. So can you see I got the data? And can you see tweet ID? airline sentiment, confidence. There's one more term, that is confidence here, right? So, I mean, are they confident about this sentiment is positive or negative? So, if the confidence is less, that means it is like clumsy, that whether it is positive, negative, they are confused. Okay. So, if the confidence is more, then it is a kind of fixed thing, that like the confidence is 100%. That means it is highly negative comment. Okay. Bad flight. Can you just see that? Hmm? A lot of things are there. You can just check it out. Okay. We can also check out the shape of this tweet, how many data we have. So we got 14,000 tweets. Can you just see 14,640 tweets with the 15 columns? So this is nothing but the shape of data. Okay, now we have to do some pre-processing as we are dealing with the natural language. So we have to do a lot of pre-processing tasks. So here, first thing, what I'm going to do is, as I have the airline sentiment confidence, that right. So I will check if the confidence is less than 0.5, it is 50%, right? So if the confidence is less than 50%, I will straight away drop that tweet, because that will not be useful. That might not be very useful for me, right? So what I'll do is I'll drop all of them. So I have applied that condition on it, and I have deleted all the data. So can you just see, after doing this segregation, from that 14,640 tweets, I got 404 tweets. So around 200 tweets have been removed from my data, right, because of the confidence issue, right? So can you just see, the confidence is sometime less. Can you just see, this confidence is very less. So this might be deleted. Okay, because I mean, it might be containing some irrelevant information. Okay. Now it's time to perform the NLP, that is tokenization, right, and everything. So the same thing I'm trying to do here. Can you just see the same thing I am doing that, stopping the remove, I'm stopping the, sorry, I am removing the stop words. All right. And then I'm using porta stemmer for that stemming purpose, right? And I'm importing string as well for the string purpose. Okay. So let's run it. The package is up to date. Now let's download the punctuations and the English stop words, right? And I am creating the object of porta stemmer. Okay. And then I run that task of tweeting. So can you just see, it is the name error which I am getting. X is not defined. What is this X right now? X dot I log length of X. What is this X? Yeah, I think I have not executed this. That's why it is not segregated. So basically, it is segregating of the independent data. Right now, it might be running. I just missed that cell. Right, it might be running now. So quite a long process, long data. That's why it's taking time, right? So we are stemming the words, and we are trying to compare it with the stop words using this for loop. Okay, that's why it's taking a long time. And now we have cleaned data. So look into the clean data. Can you just see that? Right? The @ symbol has been removed. All the stop words are removed. So now my tweets are cleaned. Now I can use them into the prediction. Okay, so I can use them into the prediction, and can you just see, everything is cleaned. Right. Although if you see the original data, a lot of ambiguities are there, right? Can you just see? So we've removed everything, and we got the things here. Okay. All right. So the next part is train. We have to train the machine learning algorithm, and we are deciding that this is my training set, by the way, right? I got a lot of sentiments here. Okay. So I have decided that I'm going to segregate the data on the basis of 3 sentiments. Is negative, neutral, and positive. Okay. So here I am applying that sentiment, and I'm using the lambda function, very famous lambda function in Python, and using that I am supplying it, right? And I am checking out. Can you see? I am converting the negative, neutral, and positive into the numbers. So this is nothing but the vectorization, a kind of vectorization, right? But actually I'm doing this vectorization here. Can you just see that count vectorizer, right? I'll perform this vectorization here using the count vectorizer, right? I'll extract features from it, right? Can you see I have extracted 3000 features out of it, right? Now it's time to train our model using the naive Bayes algorithm. So can you just see sklearn is a very popular Python library to do the machine learning and deep learning tasks, from which I'm importing naive Bayes, which I want to use. And inside the naive Bayes, see naive Bayes have three variations. There is Gaussian naive Bayes, multinomial naive Bayes, and polynomial naive Bayes. So when I talk about multinomial naive Bayes, it is the best choice when you're doing this string operations and NLP. So I've used this multinomial NB. So NB is nothing but naive Bayes. Okay. All right. And I'm also performing some training test list, which is required in machine learning. Okay. So I'm doing this. Look at that. Right. I'm doing train test split here. I'm fitting the model. This is nothing but a training. Okay. So it will take some time. The object will be trained. And now it's time to predict something. So can you just see, I'm trying to predict it using the X test part. So basically the idea is I have divided the whole data into two parts. That is the training part and the testing part. I'll give the training to the algorithm using the training data set. And then after giving training, after completion of training, I will test the accuracy of the model using the test data. Okay, that's what I'm trying to do here. So I'm doing these predictions on the test data, whether it is working fine or not. So look into this array. Can you just see 0, 1, 2, 3, 4? So basically 0 represents negative, right? So if you remember, we have decided that the 0 is negative. Can you just see? 1 is neutral and positive is actually 2. Getting it? So you've got the outputs like that only. Okay. And we can also check the accuracy of the model, whether it is it has got running it or not. Let's run it. So we can get a report, it's called a classification report using sklearn matrices. Okay. So can you just see we have precision, right? Precision on different classes. 0, 1, 2 were the classes, if you remember, right? So can you just see precision is 0.84. And you can also check out the F1 score. This is the ultimate measurement. F1 score is very good. The accuracy is also good. Can you just see 78%? I mean, it is very good to have 78% accuracy on textual data because they are highly ambiguous. It's very difficult to extract information from textual data, right? Now still we are getting accuracy of 78%. Can you just see that, right? And can you just see the precision is also good, 84%, 61%, and 70%. F1 scores are also good, little less for the category 1, but that is also okay. Right. I hope you got an idea how NLP is doing its task, and then we are supplying that processed data, that clean data into the machine learning algorithm to use it further, right? So here comes the end of this session, right? I hope you learned something from this session, and this is what we have covered, sentiment analysis and all. All right, so I hope you enjoyed the session, right? I hope you got some learning. What is NLP, how it is done, what is NLTK, what are the steps that we have to perform, right? And then how naive Bayes algorithm can help you to do the further classifier, right? From this note, right, I would like to end up this session and all the best in your learning journey. A very good day, everyone.